So here we have another example of an indefinite integral. So if we take the integral of 10x to the fourth, we're going to use the reverse power rule. So 4 is going to increase to a 5, and then we're going to divide 10 by 5. So we get 2x to the fifth minus 2 is a constant, so we can just leave it there. The integral of secant squared x is tan x, and then plus c. Okay, and one more that's kind of similar. Again, we have constants, so the 2 in front of the sine theta can just stay as a 2. The integral of sine theta is going to be negative cosine, so we'll say negative 2 cosine theta. And then we have minus the integral of secant squared theta, which is tan theta. And then we can't forget r plus c. So an equation that involves the derivatives of a function is called a differential equation, and we're going to talk more about these later on. The general solution of a differential equation involves an arbitrary constant or constants, and that's what we've been doing with the plus c. But sometimes we're given extra conditions that will help us determine the actual value of the constants so we can actually solve for a unique solution. So let's look at a couple of examples of that. So find f if f prime is equal to this and f of 0 is equal to negative 2. So we want to find the original function given the first derivative. So the first thing we have to do is find the antiderivative of this. So f of x equals the antiderivative of e to the x would be e to the x. Now this 20 times 1 plus x squared to the negative 1, we can rewrite this as 20 times 1 over 1 plus x squared. Now this, if I took the antiderivative of just this piece, the 1 over 1 plus x squared, that's inverse tan, or arctan. So we have plus 20 inverse tan of x, and then plus c. But now we know information about f. They told us that f of 0 is negative 2. So we're going to plug in 0 for all of the x's, and then we will set it equal to negative 2, and we're going to solve for c. So e to the 0 is 1. Then we have plus 20. Now inverse tan of 0, that's where on the unit circle would the tangent equal 0? And that happens at 0, right? Because sine is 0 and cosine is 1. 0 over 1 is 0. Plus c equals negative 2. So we end up with 1 plus c equals negative 2. So c is equal to negative 3. So now we know the value of c, so we're going to rewrite the f function. F of x equals e to the x plus 20 times the inverse tan of x. And instead of plus c, we're going to put negative 3, or minus 3. So now this is our specific antiderivative instead of a general one, since we solved for c. Okay, so we're going to look at another one. So here, find f if f double prime is equal to this, and then we're given two conditions. So we have the second derivative, so that means we have to find the antiderivative twice in order to get to the original. So first thing we'll do is we'll find the first derivative, because that's going to be the first antiderivative that we're doing from the second. So the antiderivative of 12x squared, so that's going to give us 4x cubed. Antiderivative of 6x will be 3x squared. Antiderivative of negative 4 would be negative 4x. And then we have plus c. They didn't give us any information about the first derivative, so we can't plug anything in yet. So we're going to find the antiderivative again and go to the original function. So antiderivative of 4x cubed is going to be x to the fourth. Antiderivative of 3x squared is going to be x cubed. Antiderivative of negative 4x would be negative 2x squared. Antiderivative of c is going to be cx, because c is a constant. And then we have another arbitrary constant that we have to add to the end of this, and we can't use c since we already used it, so we're going to add d to the end. So now we have two pieces of information, f of 0 and f of 1. Okay, so we want to use f of 0 because if we use f of 1, we're going to end up with a c and a d in the problem, and we don't know what to do with two variables. So let's put a 0 in there so that way we can solve for one variable. So we'll say f of 0 equals, we're going to plug 0 in for all the x's. So 0 to the 4th is 0, 0 cubed is 0, negative 2 times 0 squared is 0, c times 0 is 0, plus d equals 4. So that means that d is equal to 4. So in the f of x function, instead of d, I'm going to use 4 now. So I'm going to use the second condition, f of 1 is equal to 1, so f of 1, and I'm going to plug that into the f of x function. So 1 to the 4th is 1, 1 to the 3rd is 1. Negative 2 times 1 squared is negative 2, c times 1 is c, and now d is 4, and that's going to be equal to 1. So 1 plus 1, we get 2 minus 2 is 0, so we have c plus 4 equals 1, so c is equal to negative 3. So now I know c and d, so I can go to my original function, and we'll say that f of x equals x to the 4th plus x cubed minus 2x squared, not plus, because c is negative, sorry. So we're going to do negative 3x plus 4. And now this is my exact solution. Okay, and we'll just try one more. So here we have to find the position function, which is s of t, if we start with the a of t or acceleration function. So a couple of things to note. We're going to talk about position, velocity, acceleration more later on, but we've talked about it before, right? S of t is the position. It can also be written as x of t, right? Then we have v of t, which is our velocity, and a of t, which is our acceleration. If we want to go from position to velocity, we take the derivative. If we want to go from velocity to acceleration, we take the derivative. So if I want to go from acceleration to velocity, I'm going to take the antiderivative. And if I want to go from velocity to position, I'm going to take the antiderivative. So if we're given the acceleration function and we want to find the position function, we need to take the antiderivative twice. So the first thing we'll do is we'll take the antiderivative the first time to find v of t. So the antiderivative of 3 cosine t is going to be 3 sine t. Antiderivative of negative 2 sine t is going to be positive 2 cosine t plus c. Now they did give us information about the velocity, so we can plug that in. So v of 0, so we're going to plug in 3 sine of 0 plus 2 cosine of 0 plus c equals 4. So sine of 0 is 0, cosine of 0 is 1, so 2 times 1 is 2, plus c equals 4. So c is going to equal 2. So now my velocity function is going to be 3 sine t plus 2 cosine t plus 2. Oops, I guess I shouldn't box that because we're not done. So that's our velocity function. So now we want to find the position function, so we're going to take the antiderivative again. So let's do s of t. So the antiderivative of 3 sine t is going to be negative 3 cosine t. The antiderivative of 2 cosine t is going to be 2 sine t. Antiderivative of 2 is going to be 2t. And then we have a constant, and we're going to use d because we already used c in the same problem. So we know s of 0 is 0, so I'm going to plug in 0 for t. So negative 3 cosine of 0 plus 2 sine of 0 plus 2 times 0 plus d, and that's equal to 0. So cosine of 0 is 1, so negative 3 times 1 would be negative 3. Sine of 0 is 0, 2 times 0 is 0, plus d equals 0. So d is equal to 3. So now my position function, s of t, would be negative 3 cosine t plus 2 sine t plus 2t plus 3. And that is our specific position function.